In this lecture, we'll be looking at the greenhouse gas water vapor. It's actually one of the reasons why our climate is so sensitive to small changes. Water vapor amplifies a small amount of warming and makes it a big warming. Let's explore why. Water vapor and carbon dioxide are both greenhouse gases, meaning they both absorb Earth's outgoing heat, raising global average temperatures through a blanketing effect called the greenhouse effect. For example, maybe you've experienced water vapor as a greenhouse gas because on a humid summer night, temperatures stay hot because the water vapor doesn't allow the heat to escape. Now, there's a lot of water vapor in the air, but the amount varies based on location and height. Carbon dioxide concentrations are small, only making up about 0.04% of the air. Carbon dioxide is emitted through burning fossil fuels and deforestation, both caused by humans, while water vapor comes from evaporation of liquid water off of bodies of water, mainly the oceans. The amount of evaporation depends on the global temperature. A warmer Earth has a more humid atmosphere. The warmer it gets, the more evaporation off the surface of the ocean, putting more water vapor into the atmosphere. Another reason for higher humidity is that warmer air can hold more water than cold air. As the globe warms, evaporation from the oceans causes water vapor to build up. But water vapor is a greenhouse gas, so this excess water vapor causes the atmosphere to warm even further. This allows even more water to evaporate into the atmosphere, causing an even further warming due to a stronger greenhouse effect. This is an amplifying feedback, a self-reinforcing loop. In fact, this feedback is the most important of many fascinating feedbacks in our climate system. It takes a small warming, amplifies it, and makes it a big warming. Water vapor feedback play a big part in making the Earth's climate sensitive to small changes. If the global climate and the global average temperatures stayed relatively the same, the water vapor feedback wouldn't be kicked into gear. But because we're increasing carbon dioxide from burning fossil fuels and deforestation, the Earth is getting slightly warmer, kicking this feedback into playing a large role in the climate system. It's like having a skateboarder at the top of a hill. Let's call him water vapor. He's sitting comfortably at the peak, stably sitting steadily at rest in equilibrium. His buddy, let's call him carbon dioxide, comes along and gives him a little nudge. Well, this gets him rolling down the hill faster and faster as he goes down. Without carbon dioxide pushing water vapor just a little bit and getting him started down the hill, he would have stayed comfortably at rest at the top of the hill. This is how amplifying feedbacks work. They amplify changes once they are set into motion. The same thing happens in the atmosphere. Carbon dioxide acts as the trigger for the water vapor feedback. Humans don't control how much water vapor is in the atmosphere. That's up to the weather. We can control carbon dioxide concentrations, though, and by letting our carbon dioxide levels get high enough to warm the atmosphere, we are therefore responsible for triggering the water vapor feedback, amplifying the warming from carbon dioxide. If carbon dioxide warms the atmosphere 1 degree Celsius, then water vapor can cause the temperature to go up another 1 degree. But some climate myths take this science out of context. Let's look at an example. One myth related to water vapor claims, forget carbon dioxide, water vapor is the most important greenhouse gas. It controls the Earth's temperature. This implies if water vapor is a strong greenhouse gas, and we have it in large concentrations in the atmosphere, then adding a small amount of the greenhouse gas carbon dioxide can't make a big difference in the global average temperatures. The fallacy here is jumping to false conclusions. It is true that water vapor is a greenhouse gas, but that doesn't mean that carbon dioxide is not. It ignores the fact that they play very different roles in the climate system. In other words, this myth is trying to use information about water vapor to distract you to imply that an increase in carbon dioxide isn't a problem. It also oversimplifies the science. But now you know that water vapor doesn't control the Earth's temperature, but instead is controlled by Earth's temperature. Carbon dioxide is important because it controls the Earth's thermostat. If carbon dioxide levels go up, the temperature gets warmer. As a consequence, water vapor levels increase. Water vapor is the most dominant greenhouse gas, but the only way we can keep levels under control is by keeping temperatures low through lowering our carbon dioxide emissions.
This video clip shows a university professor discussing a climate change issue in a form that is suitable for school students. Let me state at the outset that most of what she says is correct. But right at the end, she gives the game away by making a totally wrong statement. And just in case you think that only she makes it, I have to tell you that this statement is repeated again and again by the climate change community. However, no one ever checks the data, and I will have a bet with you that you have never been exposed to what I'm about to show you. First, let's have her statement.
Carbon dioxide is important because it controls the Earth's thermostat. If carbon dioxide levels go up, the temperature gets warmer. As a consequence, water vapor levels increase.
Now let me introduce Dr. Don Easterbrook, who is a geologist working within a team of climatologists. At the start of the clip, he repeats her statements about CO2 and its influence on water vapor. Let's see what he has to say.
There is not enough CO2 in the atmosphere to do much of anything. And then you add to that CO2 accounts for only 3.6% of the greenhouse effect. Only 3% of the greenhouse gas effect is CO2. 95% is water vapor. So the point of this is that CO2 by itself is incapable of significant global warming. That's the bottom line. I'll say it again. CO2 by itself is incapable of causing significant global warming. And so how do we get these projections in? And we get it because the climate modelers who depend on computer models rather than real data for their conclusions have decided that if CO2 goes up, water vapor will also increase. And as water vapor increases, we kick in this 95% of the greenhouse effect. So virtually all of the temperature increase during the warm period we had in 77 to 98, virtually all of that they would account for by water vapor in their models, not CO2, water vapor. So the question is water vapor increasing? Well, here's water vapor. Here's water vapor going back to 1947. Water vapor, if water vapor is increasing as CO2 goes up, and that's what's levering the global warming, then you might have an argument for their models. But water vapor has actually decreased since 1947. Look at the downward trend. Down is less water vapor in the atmosphere. And these are various levels of the atmosphere. So in order for their models to be correct, they must show that there has been an increase in water vapor in the atmosphere, and it's just the opposite. There is less water vapor in the atmosphere now as CO2 has gone up, not more, and so their models are totally invalid. Their models will not work without an increase in water vapor.
This is probably the biggest mistake of all. It proves that all the computer models are wrong and their predictions are wrong. We are wasting both time and vast quantities of money on rubbish. Now, instead of being only negative, let's look at what we can do with climate data. The reason that we have a climate change myth at all is so that it can be used to predict how the Earth's temperature will change over time. We need to find a way to do this without relying on computer models, because Bob Carter said,
and back here in the Cambrian, carbon dioxide was, goodness gracious me, it was between 4,000 and 5,000 parts per million. On this scale is the number of times that number. So this is 5, 10, 15 times today's carbon dioxide. Well, it can't be right. The oceans would have boiled away. Surely, Bob, you know that. Dangerous global warming, carbon dioxide, it'll literally boil the oceans. Well, it didn't.
Every one of these ridiculous models in which we place so much trust that we are spending hundreds of billions of dollars betting that they are accurate predictions of our future, all of them predict that Earth's temperature would rise by such a large amount that all life would be extinguished, and hence that this is an emergency that we must prevent by taking drastic action.
Volcanoes produce more CO2 each year than all the factories and cars and planes and other sources of man-made carbon dioxide put together. More still comes from animals and bacteria, which produce about 150 gigatons of CO2 each year, compared to a mere 6.5 gigatons from humans. An even larger source of CO2 is dying vegetation, from falling leaves, for example, in the autumn. But the biggest source of CO2 by far is the oceans.
The second scientific statement uses Antarctic ice core measurements.
So here we're looking at the ice core record from Vostok, and in the red we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag, so temperature is leading CO2 by 800 years.
But if the largest amount of CO2 in the atmosphere by far, much larger than that produced by man, is controlled by the Earth's temperature 800 years ago, then we must look at what that temperature was and how it changed over time. What we see are two linked graphs. The upper one shows the ice core record of Earth's temperature, while the lower one shows how we expect the atmospheric CO2 to change in sympathy. Let's see how this evolves. Now we can have much greater confidence in predicting that CO2 levels will fall in the future, that man's CO2 emissions will not change it, and, in fact, will have a very small effect on it. But there is more that we can do as we look at the evolution of CO2 in the future. We know that the atmospheric temperature started to fall as the Earth moved from the medieval warm period into the Little Ice Age. If the 800-year lag for CO2 applies, as we predict that it does, the evolution of future CO2 over time is a marker for the evolution of ocean temperature in the future. But the evolution of ocean temperature controls the evolution of water vapor in the atmosphere. So not only can we predict the behavior of CO2 in the future, but also we can predict the behavior of water vapor in the atmosphere in the future. And water vapor provides 95% of the greenhouse effect. We see that measured water vapor is slightly decreasing over the time period, and this is inconsistent with computer model predictions that show rising levels of water vapor. But our predictions, based only on measured data, show water vapor consistent with warm oceans responding to the peak of the medieval warm period. And we predict that ocean temperatures will fall over time. This is exactly what we are seeing in the measured water vapor record, confirming that we are on the right track.